You're listening to the Skeptics Guide to the Universe, your escape to reality.
Hello and welcome to the Skeptics Guide to the Universe. Today is Wednesday, June 12, 2024, and this is your host, Stephen Novella. Joining me this week are Bob Novella.
Hey, everybody.
Jay Novella.
Hey, guys.
And Evan Bernstein.
Good evening, folks.
Kara is working today, so she's unable to join us. She had a work thing come up. So it's just the boys.
The boys.
The boys. When's the third season of The Boys coming out, by the way?
Good question.
Soon.
Yeah, it should be soon. I think we're due. That's a good episode, The Boys.
The show, you mean?
Oh, yeah.
Yeah, the show.
Yeah, you like...
I'm going to have to watch like the last couple episodes, I think. It's been
You didn't...
so
Yeah, we'll
long.
probably watch the end of the last season. It's what I like about it. It's a superhero genre TV show. What I like about it is that it's realistic in that the superheroes are all psychopaths.
Yes.
You know what I mean?
Yeah.
It's like,
Because you would be, right? Wouldn't you be?
the idea, and even if they're not, even if they're trying to be good or whatever, they're just all douchebags. Because that's what happens when an ordinary person gets a superpower. It's a little bit cynical, obviously, but still, it just shows, I think, what would happen a lot of the times. And you realize, like, the comic book superheroes are all Boy Scouts. You know what I mean? In a good way, but that's like, and you pretty much have to be that in order not to abuse your power, you know?
Yeah, because who else is going to check you if not yourself?
Exactly.
That's the only way to do it.
By the way, guys, season
Yes.
4, episode 1 premieres tomorrow.
Oh, is it really?
Awesome.
June 13th, 2 days before this episode airs.
So that's why Kara's not here today.
See, I
She
knew-
wants to talk about
Bob,
this.
I knew psychically the show was about to come out.
Yeah, of course.
Of course you
duh.
did, yeah. Well, my numerologist said it was coming
my
soon.
God. That means, oh, crap.
What's the matter,
like-
Bob? It's all
I
good.
got to watch the final
to rearrange your whole
season 3
schedule.
episode tonight.
Oh, after
Can't do
the
that because
show.
we're recording this dumb podcast.
in which we only talk about the boys.
Steve, I don't think everyone would become a psychopath.
Not everyone. I'm just saying it shows one. It shows one
Just
side.
a huge chunk.
I do think. I mean, again, they range in the spectrum from some people who are trying to be good but having a hard time to just most of them are douchebags to some of them are psychopaths, and that's probably a realistic spectrum.
Spread.
Yeah.
Yeah, how could you not let your ego get the better of you?
But I
at
also
that
think
point?
your power is a huge factor here, right?
Yeah,
Like
sure.
If you had a healing power, I don't think you would become as psychotic as if you were the Homelander,
That is probably true. If you could explode people's heads by just looking at them, it's hard not to abuse that power. How do you not abuse that power? And yeah, they just start to think that they're gods, that they're above everybody else.
Effective,
Yeah.
in a sense, they would be,
Yeah.
comparatively.
And if that type of superhero is not your thing, because it is definitely adult in a lot of ways,
Yeah.
the other side of that coin in terms of superheroes would be the show called, it's on Hulu, I think, right now, Extraordinary.
Yeah, it's another funny take on
Funny take.
superpowers, yeah.
It's a comedy, basically, but it's like 2 seasons, I think, and we just, Liz and I just finished it. It was a lot of fun. Some of the most creative powers I have ever seen. Silly creative, just like goofy, like, oh my God, can you imagine? But it's a fun show, so I just would recommend that if you like that genre at all.
And my superpower would be to be able to glow in the dark.
Yeah, I just sent you guys a picture of one of my petunias that I ordered last
Nice
week.
segue.
Yeah, so they're actually nice little flowers. They're pretty white petunias. I just got them a couple hours ago. So throughout the recording of this episode, as it gets dark, it's still light outside. Like if I could make the room dark enough, I'm going to see if I can get them to glow. They may not, because in order to glow in the dark, first of all, I have to transplant them into a larger pot. They have to grow, and they have to kind of be thriving. Like, they're not going to waste their energy making these glow-in-the-dark proteins unless they're thriving. Plus, they also need to absorb a lot of sunlight during the day, or they just need to get a lot of sunlight exposure. I don't think they're necessarily absorbing the light and shining it back. They need to have energy, to make the proteins. Mm-hmm. So we'll see. So I'm not expecting to get like a lot of glow in the dark tonight. Maybe next week, but I'll keep you updated on my glow in the dark petunias.
Okay.
But at least I have pretty petunias.
You have cats in the house, right?
Yes, they're not. Well, I'm keeping them outside. They're technically not safe for animal consumption.
Right.
It's also just that they're GMOs, so like they say, I guess they just don't want to deal with the consequences of pets eating them. I don't think they're going to be any more dangerous than regular petunias.
We'll know soon.
Well, hopefully not. I mean, hopefully I'll know if they glow in the dark soon. I don't want to find out if they're pet safe. I'm just going to keep them away from my pets.
So if you make a quick little TikTok video about it, Steve, if you're going to show video of these things glowing in the dark, put in a sound effect with that woo, woo, woo,
right.
that pulsating kind of.
Yeah.
That I would be entertained by that. Thank you.
And my daughter just bought a Venus flytrap she's trying to keep alive. But yeah, she had it inside. Like, it's not going to get any flies inside. And I was joking
Unless
with
you
her.
introduce them.
It's saying, feed me.
Feed me,
Of course.
Seymour.
Classic.
All right, Evan, you're going to get us started with a quickie.
Yeah, a quickie from Evan, which is, I don't know. Have I done a quickie before? Don't even remember. So, this one. Then, look, the next time you're searching for some science news, here, I have a suggestion for you. Type in the term scientists baffled. All right. You might be surprised at how often scientists are baffled. And apparently it happens every day about something. And in a way, you have to stop and think about it and you say, well, duh, science, yeah, it's a never-ending endeavor that attempts to explain the billions, if not trillions, of observation that people are capable of making about everything in the universe. Yeah. So it's part of the job. It's part of the journey. But there's still something about baffled scientists in a headline that makes you want to slow down and take a closer look to see what has them puzzled. And that's what happened to me. Scientists are baffled by a mysterious 53-minute signal from space. 53-minute signal, yep. Now, they know what's emitting the signal. It's a neutron star named ASKAP J193505.1 plus 214841.0. Or, as they put it, I'll read it here, ASKAP J1935 plus 1248 for short.
Oh, my
Thank
God.
goodness they shortened it
Just
by
call it
taking out those
ASCAP.
decimals. I mean, seriously, they gotta, I don't know. That whole system is, I understand it has to do with, what device picked up the signal and where its coordinates are in the sky. I get all that, but come on. It is in the plane of the Milky Way. It's about 15,800 light years from Earth. And this neutron star. Yeah. So neutron stars, right, Bob?
Love 'em.
This is what's left after a star within a certain mass range dies. About 8 and 30 times the mass of our sun. The star's outer material is blasted off into space, culminating in a supernova explosion. And then the leftover core of the star collapses under gravity, forming an ultra-dense object up to 2.3 times the mass of the sun in a sphere just 20 kilometers or 12 miles across. Size of a city, as Carl Sagan used to say.
Size of a city. Not enough mass to blow past the neutron degeneracy pressure. Because if it did, then it would be a black hole. But it's not quite enough mass to do that, so it hangs out as a neutron star. One of possibly the most fascinating objects in the known universe.
But Bob, this particular neutron star has a pulsation period of 53.8 minutes. The only consistent aspect of its pulsations as well, because the signal, every time they measure it, they say it goes through 3 phases consisting of periods of strong pulses, then periods of weak pulses, and then periods of no pulses at all. That classifies it as an irregular and long-lasting signal source. These objects are specifically called, they're specifically called long-period radio transients. They are very rare. This is the third one apparently to have been detected so far. And of the 3, this has the longest period as far as radio transient objects go. It was first identified serendipitously during observations of a different target, but then they started to make some follow-up observations. And the researchers dove into some previous observations when the telescope in Australia was covering that same patch of sky. Manisha Caleb, she's the study's first author and astrophysicist at the University of Sydney. Here's what they had to say in their report. Using ASCAP, ASKAP, we were simultaneously monitoring a source of gamma rays and searching for pulses from a fast radio burst When we spotted this neutron star, I won't go through the designation again, slowly flashing in the data. The signal leapt out because it was made up of circularly polarized radio waves, which means the direction of the waves corkscrews around as the signal travels through space. Our eyes cannot differentiate between circularly polarized light and ordinary unpolarized light. However, this telescope's functions like a pair of Polaroid sunglasses, filtering out the glare from thousands of ordinary sources. And after the initial detection, we conducted further observations over several months using it. And they also used the more sensitive Meerkat radio telescope in South Africa. Now, they noted that these objects are known to emit radio waves, and the observed irregularities in the signals might be due to the presence of strong magnetic fields and plasma flows associated with the neutron star. Plasma. But
Is it a magnetar?
Well, yeah, they're not. They don't know, Bob. They think maybe. I'm about to get to that. I'm just about there. They say that some properties of neutron stars align with the observed signal behavior, but there's a problem. No known neutron star rotates at a speed that would allow for a signal emission every 53 minutes. The current understanding indicates that neutron stars typically rotate around their axis within seconds or fractions of a second. Yeah, right? So 53 minutes for a neutron star, not really possible.
Yeah.
Well, what's the other? What else could it be?
Is it tumbling in a way that it's it's only occasionally lining up with the Earth? But that would be a weird spin, a spin and a tumble. I don't think that's even a thing.
But they say nearby also is a white dwarf, and perhaps that's the candidate for this signal. White dwarf, Earth-sized cinder of a burnt-out star that has exhausted all its fuel. But white dwarfs, and yes, they do, they rotate more slowly. But they've never known a white dwarf that could emit such a strong signal as this one. So you're in this place where you have neutron star, but doesn't have all the features of neutron star, or white dwarf doesn't have all the features of white dwarf. And so what's their best guess? Well, here's what they're saying. They're saying it's probably part of an older population of magnetars. There you go, Bob.
Yeah. With
long spin periods and low X-ray luminosities, but magnetized enough to be able to produce coherent radio emissions. And it's important that they probe this unexplored region of the neutron star parameter in space to get a complete picture of the evolution of neutron stars. This may be an important source to do so. If you want to read more about it, they published this in Nature Astronomy. And that's been your Quickie with Evan. I'll also be back in about 53 minutes with another news item.
All right. Thanks, Evan.
Cool, man.
You're welcome.
Guys, do you know what ultra-processed food is?
Yes, I do.
Ultra-processed.
All right.
I hear that term regularly.
Yeah, right. Don't you hear that term? So what is it? Well,
it's
Jay?
Twinkies. It's basically
but
Twinkies.
give me a operational definition.
Well, they take the food and they process it like way more than regular food.
Like crazy.
Yeah, like go crazy.
Like ultra, mega.
Yeah,
I think what do? They strip out basically everything that's good for you.
That's the opposite of the usual definition. It's not what you take out of it; it's what you put into it. But it's actually there is no real agreed upon specific definition, and there's no objective difference between, say, processed and ultra processed. Different studies might use different criteria for the study. Like a recent study that I'm going to be talking about said if you have 5 or more additive ingredients, then that's ultra processed.
So 5 or more.
Right. But that could include a lot of things. So if you buy bread at the store, that's ultra processed food.
Mm-hmm.
Right? Bread. Of course, anything like Twinkies would fulfill that definition. So some of the types of ingredients are preservatives, right? Things that prevent, contamination, bacteria,
extend shelf
mold.
life.
Yeah, so it extends the shelf life, makes the food safer. Other things would be like emulsifiers that keep the consistency good. Things like coloring, which just makes it more visually appealing. There's a host of things that, that manufactured food that is added basically to make it safer, longer shelf life, tastes better, more appealing, more visually appealing, better mouthfeel, all that stuff, right? So the ultra processed food, however, has been getting a lot of attention recently because of some studies showing that there's a correlation between eating ultra processed food and all-cause mortality, right? So if you eat a lot of ultra-processed food, you're more likely to die sooner, which is...
Okay, kind of like tobacco and smoking and longevity.
Except that this is not real.
Aha, big difference. Big difference.
This one is fiction.
Well, it's just that the data is crap. And it's partly because they don't have a really meaningful definition of processed or ultra processed. But the data is, as you might guess, observational. The most of the data is coming from a French online health survey, the Nutrinet Santé, which has spawned multiple studies. And this is the one that most often gets referenced in data coming out of this database. And they found, basically the bottom line was they found a correlation, an association with a 10% increase in all-cause mortality and high consumption of ultra-processed food. There was also a more recent study where they looked at just ultra-processed food that's based on plant material, and they found that it also had a higher mortality rate. But here's the problem. What's the problem with observational studies, or the weakness? Not that you can't get useful information out of them, but what's the primary weakness of an observational study? So observational studies are not controlled, right? They're observational. They're not experimental. You're not telling which people can eat processed or unprocessed foods. You're just asking people what they are already eating, and then following them or looking back to see, like, how many heart problems did you have? How many people died, etc. So it's uncontrolled data. So again, what's the problem with uncontrolled data? Is not bias, but confounding factors, right?
Yeah.
Sure, yeah.
Because you're not controlling
what else is going on.
Yeah, you're not randomizing. You're not assigning people to random categories. And so there could be lots of things that correlate with eating ultra-processed food that might in and of itself be a risk factor. So what do you in this study, so in the main database, that is being used to drive this narrative that the press loves, that ultra-processed food correlates with higher risk of dying. What do you think were some of the confounding factors? I'll just tell you what they are.
Income had to be one of them.
Income, right. So the typical profile of somebody who eats a lot of ultra-processed food is low education, low socioeconomic status, high body mass index, lives alone, and more likely to be male. So basically, and also more likely to smoke and less likely to exercise. So these are people who are overweight, not exercising, and they are low socioeconomic status, low educational level, and have a lot of other health risk factors, right? So, I mean, come on. Of course they're dying faster, given all of that. You can try to control for those factors, but it's obviously such a massive correlation with lifestyle factors. There's no way you're going to tease apart all of the other confounding factors that are in there. It's just not possible. Here's the other thing, is that if you look at that data and you control for a couple of things, one, if you eliminate people who were sick to begin with, or people who died within the first year of the study, meaning there really wasn't enough time for any unhealthy effect to take place, the correlation goes away. So it doesn't hold up over time. If you start with just looking at people who they don't have any major illness to begin with, not that they're healthy, but they don't have anything that's going to kill. They don't already have heart disease or diabetes, whatever. You start with the healthy people, and then you see you follow them for who dies and who doesn't die. There's no correlation there. So nutritionists, the nutrition people, are not impressed with this data. And just generally speaking, scientists who have reviewed this, there's a ton of problems with this data. It doesn't really, you can't use this as a basis to say that eating ultra-processed food is a risk factor in and of itself. It's not what we call an independent risk factor. It's just a marker for a lot of other risk factors. Does that make sense?
Yeah. More of an indicator of kind of the lifestyle the person might be leading.
I mean, think about it. Of course, because why? Because eating processed food, prepared food, basically, it's convenient, right?
Fast,
it's cheap and convenient, as opposed to the other thing is, and there's so much data to support this. If you have a home structure, you have a spouse, you have other people in your life, that in and of itself is a massive benefit to your health. Sure. Imagine the lifestyle where you have a home cooked meal with a family versus microwaving something alone, at nighttime.
You can't compare the two.
Yeah, these are two completely different lifestyles. You can't just pull out it's the food, it's the ultra processed food that's called. No, it's silly. So no one's really convinced by this who looks closely at the data. But the other problem with it is that it's, in my opinion, and the opinion of a lot of nutritionists that I've read, who have commenting on this data, it's looking at the wrong thing, right? So you're just saying, we're going to look at how many ingredients are added into the food, as if that is somehow adds up to a risk factor. Of course, each of these ingredients individually is approved by the FDA in this country or similar, regulatory bodies in other countries as safe, right? So these ingredients have all been studied. So why would having multiple safe ingredients somehow be unsafe?
Only if you're reaching toxicity levels.
But these are different ingredients. But you're not. But again, these ingredients are approved because you have to prove basically that you're safe at an amount that could be reasonably consumed, right?
Mm-hmm. Yeah, reasonably consumed. Sure.
So here's the other thing, though. It is true that processed food can be high in fat, sugar, and salt, right? And so having a diet high in fat, sugar, and salt is a risk factor, right? Salt could be a risk factor for hypertension and therefore strokes and heart attacks. A high sugar diet can cause diabetes. High fat diet is also not good for your weight control, etc. So there may be a signal in there of also a correlation with eating too much fat, sugar, and salt. But the thing is, that's not universal to ultra-processed food. You could also get a lot of fat, sugar, and salt from home-cooked food too, right? From buying raw ingredients and cooking it. You could be buying steak and cooking it, every night and adding a lot of salt to it or whatever, So the messaging is all wrong. You shouldn't be...
Yeah, you could have the same problems with non-ultra-processed food.
Right, exactly. And it also, if you think about it as a public health measure, do you really think it's going to be effective to tell people don't eat cheap, convenient food? The people who are eating it probably don't really have the option not to. You know what I mean?
True.
And also, for example, let's just look at the low socioeconomic status people. A lot of people who are low SES who consume a lot of processed foods live in a food desert, right? They don't have access to fresh produce, or it's very difficult or very expensive for them to get fresh produce. So it's not necessarily a lifestyle choice so much as a necessity. They kind of have to eat cheap processed or fast food or whatever, you know what I mean? So just saying, don't take this option that kind of is built in to either your lifestyle or your socioeconomic status or whatever is not going to be very effective. What you need to do is give a simple, effective communication about, keep an eye on how much sugar, salt, and fat you're eating. If you just said that rather than avoid ultra-processed food, that would be much more effective. But also, the evidence shows that telling people what to do isn't very effective at all anyway, whatever it is, whatever you're messaging. I mean,
We've talked about that.
Yeah, some messaging is better than others, but none of it is terribly effective. So if we wanted to handle this at a societal level, what could we do? The short answer is we don't know, but there are some things that experience and research has shown to be helpful. And one of those is labeling. So mandating accurate, transparent, and readable, understandable labeling and not allowing deliberately misleading labeling, it could go a long way to helping people make healthier choices, even if they are consuming processed foods. Plus, it also can force the industry to think very carefully about what they're putting in their products. Are you really going to put that in there just to make it a little bit more tasty when it really will just, make it much less healthy, for example?
Yeah.
But there's kind of an arms race for the things that consumers can perceive, right? Which is visual appeal and taste. But they're not so much for being healthy. The thing is, the arms race for the health halo is mostly fake. Right? That's a huge problem. So think about walking through, and believe me, I think about this every time I walk through the grocery store and I look at packaging, I look at labels. The things that are prominent on a lot of labels are all bullshit. They're all
Right.
meant to convey a health halo, but are not really giving accurate or useful information. So one, of course, that drives me nuts is the whole GMO-free, non-GMO labeling thing.
Yeah.
That's all marketing hype
Marketing.
BS. Has nothing to do with your health. You could pretty much guarantee that anything that's labeled as low fat has a lot of sugar in it, or anything that's labeled as low sugar has a lot of fat in it, right? So that's kind of the game that they play. They get you one way or the other, but they lull you into thinking this is a healthful product by giving you limited information, cherry-picked information, without giving you really all the information you need to have. I mean, it's there. You know, you have to look for it. You have to know how to read the label. And
That's the key, Steve.
Yeah.
Learning how to read the damn label.
But you shouldn't have to. It should be obvious. One thing that kills me, if you guys had this same experience, you like say, how many calories are in this thing, right? And it's surprisingly low. And then you realize, oh, that's per serving. And there's like
14 servings
there's
in the
like
box,
6 serving or whatever. Like they just arbitrarily, a serving is a half a cookie or whatever. Like they come up with these ridiculous arbitrary servings to make, just so that anybody who's like glancing at like, oh, it's only 150 calories or whatever.
So they can peg a certain number which lights up.
Right. It's meant to deceive. It's not meant to inform. So accurate, transparent labeling has been shown to help people make better decisions and does also sort of put pressure. Again, it makes the healthfulness of the product more marketable and more something that the consumer can choose, right? The market will not favor healthful choices if that's all deception and being hidden really from the consumer, right? The consumer market forces can only operate when consumers have the information that they need, and they're not operating under too much misinformation. So there have been a lot of efforts, to improve labeling, and they have gotten better over the years. But still, I find the end of the day, it's really hard, and it doesn't, and it shouldn't be that hard. But just using a heuristic like, well, just don't eat processed foods isn't really very helpful, because you'll be surprised what counts as quote unquote processed. If you go to a bakery, like anything you're not cooking in your home yourself, like I said, like if you're not baking your bread yourself, any bread you're going to buy anywhere would count as processed or ultra processed, because they have to include these ingredients. And again, the ingredients themselves are probably not the problem. There's no reason to think that is the problem, or that it is even a problem, or that, again, they haven't even established that these dietary choices are a problem. It's just that it correlates with a lot of unhealthy lifestyle situations, right? So, anyway, it's just, I think, one more way to divert the public's attention away from what's really important, to boil it down to just a buzzword, ultra processed, which is useless and deceptive and misleading. It's a distraction, and it's going to be counterproductive, in my opinion. All right, Jay, tell us about Artemis's new spacesuits.
Well, it's more of just an update on what's going on with the Artemis program. So, Steve, this is NASA's plan to get people back to the moon. It hasn't happened since 1972. So now the new date, I think we said this before, it's 2026. I was really hoping it was going to happen next year, but that seemed very unlikely recently. So the mission is named Artemis 3. Try to remember that, because we're going to be talking about that mission for a very long time. So in general, the mission has new rockets, new spacecraft, new spacesuits, all sorts of technological advancements. Every system has been improved. So in late April of 2024, very recently, 2 astronauts, Peggy Whitson and Doug Wheelock, conducted the first tests of the Axiom Space's new spacesuits, and they used a mock version of SpaceX's Starship, which is the Starship Human Landing System, HLS. I'll just call it Starship, okay? The test is the first of its kind since the Apollo missions, and the goal, of course, is to evaluate the compatibility of the spacesuits with Starship's physical layout, design, and clearances, right? Clearances mean headroom and room to maneuver around, particularly when people are wearing spacesuits. Like, they can't move like you would if you weren't wearing a spacesuit. So things have to be a lot easier to reach and grip and everything. So I was surprised to read it was only a 3-hour test, but I guess that's all it took for them. They did the test at SpaceX's headquarters in Hawthorne, California. And basically it involved the astronauts wearing the spacesuits, and then they were interacting with a control panel inside a full-scale airlock mock-up, which I would love to see. This test proved that the controls were accessible and operable while wearing the spacesuit gloves. I know that sounds like, yeah, of course, but they have to test it. They can't just build it for the gloves. They have to see.
Oh, yeah.
You know what I mean? It's a very
course.
simple test that shows you everything. They also practice using this elevator that's going to transport the astronauts and their equipment from the Starship deck to the moon's surface during the Artemis missions. And just saying that sentence made me so excited because I'm visualizing like two astronauts standing on a platform with cool equipment and like these like space-faring cargo crates, and they press this freaking button that's on the end of a long yellow electrical cord, right? And it's like, and it goes down to the surface, and astronauts are stepping on the freaking moon again. And it's gonna happen exactly like I just said it, at least in my dreams. No, but it's gonna be very similar to what I just said. Logan Kennedy, who is the lead for surface activities in NASA's HLS program, he observed and confirmed that the suits allowed the successful operation of the control panel and the astronauts' ability to perform the tasks that they're going to be doing before they actually step on the moon's surface, right? So this is all like at the airlock, last things that they're going to do before they walk out onto the moon. And the test also confirmed that the airlock and the deck and the elevator space were the right size, for what the astronauts are going to be doing. Like they know at this point with pretty good precision, like what the astronauts are going to be doing in those spaces, like the order of events and what they need to carry. And if there's anything that they have to do, they basically know what that is. And they went through that. And if you haven't seen the spacesuits recently, I suggest you look them up. They're pretty cool looking. And these are the ones that are going to be on the moon. They're known as Axiom Extravehicular Mobility Unit, or AXEMU. Like, come on. Like, these naming conventions are terrible. Like, what?
It's better than that neutron
star. Can you bring the AXEMU over? Bring me the new spacesuit, right? Let's just call it the spacesuit, okay? Yeah. We don't need these.
Let's call it a space tux.
Whatever. Anything other than AXEMU. Get out of here with that. I don't get that. This is where engineers I'm sorry, guys. You're brilliant, and I love you, every fiber of your being, but you cannot come up with cool names.
But if they leave it to the public to name it, they'll come up with Sooty McSuitface.
Whatever. Still better.
That's not too bad.
Huh?
So they first unveiled these spacesuits back in March of 2023. I remember we covered that. The suits are designed to be worn in flight and on the lunar surface. That's a big deal, right? The suits have to operate in two very different situations. Believe it or not, like these tests that they're doing, like they are life-saving tests. You don't want a glove getting stuck in some mechanism anywhere, right? Every handle hold that they have and everything was designed with the glove in mind, but they have to put it in the physical space and see it operate. Lots of people are watching as they do this to make sure every single thing that they could possibly think of that could go wrong, they fix it out. They get rid of it.
Yep. No space love without the glove.
Definitely, man. So in April, Axiom tested an unoccupied spacesuit in NASA's Neutral Buoyancy Laboratory, the pool, adding weights to to mimic the lunar environment, to make it simulate as close as they could to what the gravity will be on the moon. And an astronaut, they're going to do a fully suited water test soon. And of course, everybody's hoping that this goes really well because the less snags, the quicker they get to the moon. Now, SpaceX has been making really, really good progress working out the kinks with Starship. As you know, there was a recent launch that went really well. They want Starship to be fully reusable, which is going to make the moon missions and the Mars missions much, much less expensive. So the recent successful fourth test flight, which was on June 7th, showed that a lot of progress has been made. They had a smooth water landing for both Super Heavy Booster and Starship, which is all great. This is all good, man. This stuff is functioning. They're still finding a lot of things that they want to update, but there's no major flaws that they're dealing with right now. So here's the big but. Despite all of these awesome advancements, and everything has advanced in the last year, right? If we just look at what they've done over the last year, lots of progress has been made. But NASA postponed the moon landing to September 2026. So we are a year and about 3 months out, which is not that bad. It's reachable. It's going to happen. Now, this is due to the issue with the Orion spacecraft's heat shield. You guys remember the heat shield problem? The life support systems and electrical systems in the crew abort system. Like all of these things were having issues. I guess NASA pretty much freaked out and were like, nope, we are not even close. And they had to like fix everything and do a lot of re-engineering and fixing of things. So this is exactly what they need to do in order to send people to the moon. NASA assured the mission will launch only when it's safe and fully ready. Now, that sentence that I just said right there, guys, that is the big safety of September 2026 might not happen. So
yeah, not surprised.
So they think that they can do it, and they are full steam ahead, and an incredible amount of people and money has been leveraged to solve all these engineering problems. But this is good. They're like, nope, if it's not 100% and we don't feel 100% that things are going to go, they're not going. And of course, that's the way it has to be. So NASA officials have indicated that the timeline for Artemis 3's launch depends heavily on the readiness of SpaceX's next-gen Starship system. Again, it's doing well. The Starship system is doing well. But so the NASA officials did indicate that the timeline for Artemis 3 is in flux. They said, it's in flux. We think September sounds good, but we'll see. And one last cool thing, just to remind everyone, Artemis is a program that is a collaboration with over 30 international partners. So this is a big deal around the world.
Wow.
Lots of countries are involved, lots of investments happening, lots of people wanting this to happen. I don't know. There's something human about this that I think is essential. Like, we need these types of things going on, particularly in a world where so much crazy stuff is going on. Like there's wars and horrible politics going on and all of this crap. What are the big, awesome things that we could all look at and agree, that's awesome? This is it. This is it. The space program, in my opinion, has always been this brightly burning torch of achievement and forward-leaning, and let's make science fiction science. And I think that's a freaking awesome goal.
Yeah, I agree.
Thanks.
Mm-hmm. But how are the suits?
They're all right. They're cool. I mean, you know what? Look, from a fan of science fiction and a fan of every spacesuit that's ever been since the Mercury missions, they're fine. They're cool. They're very modern. They don't have like this massive, awesome, like holy crap appeal that I was hoping that they were. I was hoping they were going to come up with something that is like a lot thinner, not so bulky.
More Hollywood, like The Martian.
Yeah. Definitely. Mm-hmm. But they came up with what's functional and what's going to work. And the spacesuits, man, that's a big deal. Like, we've talked about this in the past. They used to have two sizes for the spacesuits. There wasn't one that would fit women for the most part. They have come a huge way since then in making these very much like many, many different sizes and being able to conform to lots of different body types, which I think is great. But again, what you think that they'd have a ton of these spacesuits, they don't.
No, because they're damn expensive.
Yeah, they're crazy hard to make, and they're not falling off the rack here. Like, these things are rare. They're rare. Like, I wouldn't be surprised if they had 2 suits that were ready, and that's it by September of next year.
What?
Yeah.
Only.
Yeah. Yeah, Bob.
So there will only be 2?
I'm saying, this is me. Of all the reading that I've done, I wouldn't be surprised that when September 2026 comes around, they have 3 freaking suits ready.
Yeah. It's funny, like, before we started reporting on it, I never would have guessed that, like, designing an updated spacesuit was going to be a limiting factor to, like, the Artemis program.
Yeah, right?
Right? Why is that the stumbling block? It's a friggin' spacesuit.
Right. You thought they cracked that egg 50 years ago, you thought.
Yeah.
Right?
No.
Yeah, I know I get it. We talked about all the reasons why it's way more challenging than the Apollo mission that has to last a lot longer, et cetera, et cetera. Those were designed to be one-off suits that would last a week, and that's it. Right. And so I understand. And then since then, we've designed suits for space, but not the moon. And now I get it. I get all that. But even still, it didn't seem just superficially like that hard of a problem to me to make a decent spacesuit.
But it goes to show you that, like, you'd think, oh man, the new rockets, this super crazy complicated stuff, and it's this type of thing that is super difficult, right? And it's no coincidence that it's the human interfacing thing.
Yeah. Right.
You know, like building an engine out of steel and all these, you know, it's like that seems like for some reason like much more achievable and easy to get to compared to like putting a human inside a thing that has to have all of this stuff going on at the same time.
Yeah.
You know, those suits are like, they are no joke, man.
They're little spaceships.
Yeah, they are. They're personalized spaceships. I guys, I was wrong. It's not a year and 3 months. It's 2 years and 3 months
For the launch.
for the launch.
Yeah.
Yeah. So that, again, that's not a lot of time. It's not a lot of time to like, if they have to redo anything, they're not going to make that date.
Yeah. And
You
we
know?
still don't have a lander either.
It's all being worked on, Steve.
I know.
We gotta stay positive.
One thing at a
man,
time.
You know?
I know. But until those boxes get checked, I'm nervous.
I hope they attach a camera to everything.
They've got to,
at
Ed.
every angle, multiple cameras per Astra person.
Yeah, like on
astronaut.
them, on the ship,
Right?
on the
Yeah.
like throw something out
Body
the freaking
cams, the
window
whole
that
thing.
you know, like deploy a camera off the ship and record the entire goddamn thing from soup to nuts. I want to see them like everything that they do.
And don't erase the tapes later. I know there's no tape, but that's the thing. But right, isn't that a tragedy?
It is crazy.
Totally tragic. And yeah, you still with all that, you'd never convince everyone that people are actually on the moon.
Oh no, it's a top. Oh
my God.
AI did it. Yeah,
I didn't
that'll
realize that. This is going to cause a resurgence of moon hoax.
The haters are going to hate
Sure.
Bob. Screw them. Look at this. There's a couple things I want to say. Talk to your friends and family, and especially kids, about this. Get them excited. Have them build up the anticipation of this. And we're going to have 2 astronauts. We're going to have a man and a woman on the moon together for the first time. And they're going to both say something profound. And I can't wait to hear what they have to say when they get on the moon. I'm sure they're going to prepare something. But
may
we're
be
also going to hear
disappointed.
them talking about...
Please don't misspeak this time.
We will hear them talking to the world about
That was a
their
technical
experience.
glitch.
Yeah.
It's going to be freaking awesome, guys.
All right, Bob, tell us about interstellar clouds interacting with the Earth.
This was fascinating, guys. Researchers conclude that it was possible that 2 to 3 million years ago, our solar system spent at least multiple centuries passing through a dense interstellar cloud, exposing the Earth to radiation and chemically influencing the atmosphere and climate, and perhaps even human evolution itself. This was a paper published in Nature Astronomy. The title is A Possible Direct Exposure of the Earth to the Cold, Dense Interstellar Medium 2 to 3 million years ago. A very interesting read, not too jargony. I recommend it. The lead author of the study is astrophysicist Merav Ofer, an astronomy professor at Boston University and fellow at Harvard Radcliffe Institute. Now, extreme climate changes to the Earth, I'm talking like ice age type of changes, are usually attributed to things like carbon dioxide levels or volcanism, plate tectonics, or a host of other things that are about the Earth, or at best, the Earth-Sun system. The authors of this paper contend that we may need to also factor in as well the location of the Sun in the Milky Way itself. Let's use our imaginations. Imagine the Sun is moving in its orbit around the galaxy. Say it's 10 to 20 million years ago. So the Sun is moving through the galaxy, and up ahead is a series of closely spaced supernovae that explode, and they push away much of the gas and dust that was there, forming a huge bubble of cleared out or low density interstellar space. And this bubble is huge, hundreds of light years. At this point, as it evolves over time, it gets bigger and bigger, and now it's hundreds of light years across. This is called the local bubble. The Sun entered the local bubble about 5 million years ago, and it was kind of nice and clean in there. You know, it's been cleared out by these multiple explosions. There was only 0.001 particles per cubic centimeter. So, yeah, not even a cubic centimeter had a thousandth of it was
A clean
very
room
sparse.
in space. Yeah.
Oh my God, yeah, be far beyond that. Now, within that local bubble that we entered, there's other interstellar clouds of various densities. Still not very dense generally, but most of them are, they're a little bit more dense than the local bubble. Now, we're currently sailing through a 30 light year wide cloud bubble called the local interstellar cloud. So this is denser than the local bubble. instead of 0.001 particles per cubic centimeter, this is zero point 0.3 particles per cubic centimeter. So yeah, it's denser than the local bubble, but nothing to write home about. Okay. Now, as stars move through space, the stars interact with the interstellar medium, right? The sun is embedded within the interstellar medium. I mean, not directly, but their magnetic fields and solar winds expand outwards from the star, right? They expand outwards together, creating a protective shell called an astrosphere. Isn't that an awesome word? I never heard that word before. An astrosphere. Mm-hmm. The sun's astrosphere is called the heliosphere. We've mentioned that many times.
I've heard of that.
Right? Mm-hmm. We've heard that many times. And our heliosphere extends about 130 AUs, astronomical units, away from the sun. That's 130 times the Earth-Sun distance. The Earth is about, on average, 93 million miles away from the sun. So 130 times that. That's where our heliosphere ends. That's 11 billion miles away, or 18 billion kilometers. So that's our protective cocoon or force field, however you want to look at it. It protects us from various things that are in the interstellar medium. But we're going through a very, low density. We're in a low density bubble. So there's not a hell of a lot out there in terms of particles, but there's also galactic cosmic rays and radiations and other things that are still harmful. So we're protected within our heliosphere. Now, when we first entered the local bubble, think about this. Our sun and its heliosphere is entering this very low density local bubble. And what do you think happens to the heliosphere? It gets bigger, right? You would think you're going into a lower density medium, so the heliosphere has less pressure against it, so it's going to expand a little bit. And that's probably exactly what happened. Our heliosphere got even bigger than what it was. Conversely, though, if the sun and its heliosphere enter a much denser cloud than what it was, the heliosphere shell around the solar system would probably shrink, right? It would get smaller because it's surrounded with a higher density medium. It's tougher to plow through it. So this heliosphere is going to shrink back a bit. So this is where astrophysicist Merav Ofer and her latest research comes in. She's an expert on our heliosphere. Does that make her a heliospherist? I just made that word up. I don't know. I like it. She's not just a heliospherist. You can say she wrote the book on it, or perhaps she wrote the model, because her models of the dynamics of the sun's heliosphere are so useful and so illuminating. She's preeminent in her field. Everybody listens to her. So I'm just setting the stage. I mean, she is quite impressive. So using her newest models to trace the sun's movement through our local bubble in the past, Merav and her team show that it's possible, not likely, but it's possible that we went through a very dense, very cold hydrogen cloud 2 million years ago. Very dense. Now, the interstellar cloud that we went through, it seems, is called the local ribbon of cold clouds. That's the name of it. It's like a ribbon of clouds, of these interstellar clouds that are very dense. They think the density of the cloud that we perhaps went through, they think was 3,000 particles per cubic centimeter. That's 10,000 times denser than the bubble that we're in now, the cloud that we're in now. And it's 3 million times denser than the very not dense local bubble. So this is a much denser cloud of particles, of hydrogen particles, in fact, than what we're in right now. So what does that mean? What does it mean to have the heliosphere, to have our sun and Earth go through such a dense cloud? Now, remember when I said that our protective heliosphere would shrink if we entered a denser cloud than what we're in now? How much do you think it would shrink? Merav calculates that our heliosphere would shrink from 130 AUs to 0.22 AUs.
0.2? What does that even get you to Mercury?
0.22 AUs. So I hope your eyes just widened involuntarily.
Basically goes away.
It's meaningless.
Effectively
It's meaningless
nothing
to the
for
Earth.
Yeah.
That means that our heliosphere shrank like a critical part of Jay's anatomy when he jumps into a very cold pool.
Jesus.
It just like
Now
went.
the world
"Bah!"
knows. Thanks, Bob.
Well, we'll all move to Mercury and be safe there, I guess.
So if this happened, then Earth has no protection from the raw interstellar space for a period of time stretching, they calculate, from 2 centuries to 1,000,000 years. That's a long time. This isn't like a weekend. The low end was 200 years, where we're basically embedded in just raw interstellar space, which wouldn't be a lot of fun even just in the local bubble. But now we're in this dense cloud of molecular hydrogen.
I want my new superpower to be to control the heliosphere at my will.
Yeah,
so I can compensate.
That
for
would
this.
be helpful. Although, if you went back in time, I might have to kill you to prevent you from doing that 2,000,000 years ago, and I'll tell you why. All right. So one thing the heliosphere does is filter out radioactive particles that are from supernova. So supernova just spew all sorts of radioactive particles all over the place, and some of them embed themselves into interstellar dust grains. And that includes isotopes like iron-60 and plutonium-244. So this is what the heliosphere filters out for us, these radioactive particles that have been embedded into the dust grains. But without the heliosphere, that doesn't happen. So we have actually found iron-60 and plutonium-244 in the ocean, on the moon, and in Antarctic ice cores. We have found them. We've known about them for many, many years. We thought, and some scientists still do probably, think that they came directly from nearby supernovae. Even with our normal heliosphere protecting us, if a supernova is close enough, then some of this radioactive particles are going to get past the heliosphere. It's not a perfect filter, but that's actually looking less likely that it was caused by supernovae directly, because the other corroborating evidence that you would expect to see and have with nearby supernovae isn't very strong. They're not really thinking so much that perhaps it came directly from supernovae. So in my mind, that of course increases the odds that we have those radioactive particles on the Earth because we had no heliosphere, perhaps. But also, if you look at the timing of these radioactive particles, they actually match periods of cooling for the Earth back then. So that's another little bit of evidence right there. So the next question becomes then, could a shrunken heliosphere, basically a heliosphere that is irrelevant for the Earth, could that cool down the Earth because of we had such intense exposure to this very dense molecular cloud of hydrogen, essentially, like I said, the raw interstellar medium with no protection? We're not sure. We're not sure what exactly would happen, but the researchers think that just by having these dense hydrogen clouds right outside Earth's doorway could certainly, at the very least, impact the chemistry of Earth's atmosphere. What does that mean? We're not sure, but it would definitely have an impact on the chemistry. That's clear. They say in their paper, very few works have investigated the climatic effects of such encounters quantitatively in the context of encounters with dense, giant molecular clouds. Some argue that such high densities would deplete the ozone in the mid-atmosphere and eventually cool the Earth. So there are a lot of scientists who think that there would be some cooling because of the impact on the ozone to having such this molecular cloud of hydrogen right outside our front door. Even more compelling is the idea that this could have also impacted our own evolution. In their paper, the researchers say it's been suggested that climate changes around this time could have affected human evolution. The hypothesis is that the emergence of our species Homo sapiens was shaped by the need to adapt to climate change. With the shrinking of the heliosphere, the Earth was exposed directly to the interstellar medium. So yeah, this argument seems a little bit less strong. I mean, they seem to be basing it on the idea that Homo sapiens, evolved with a selective pressure of dealing with a lot of climate change, which could have been caused by the disappearance of the heliosphere. So maybe it did. Maybe it did. I think it'd be a little harder to definitively show that. But it is interesting to think that something like, this dense cloud that we went through for centuries at least could have actually had a significant hand in our own evolution. obviously kind of speculative, but still fascinating. So now the authors, they agree that there's lots of unknowns. A lot of these questions that we're discussing right now, they recognize that it's beyond the scope of their paper and needs to be investigated. Ofer and her colleagues are now working to see where was the sun 7 million years ago, not just 2 or 3 million years ago, but 7 million years ago. Did the sun go through another dense interstellar cloud and cause the heliosphere to disappear even another time and potentially influence Earth's climate and even evolution? So they're looking into that. I'll end with their closing quote in their paper. We hope that our present work will incentivize future works detailing the climate effects due to an encounter of the heliosphere with the local ribbon of cold clouds and possible consequences for evolution on Earth. So there you go. Interesting stuff. I just never imagined that the heliosphere could have just said, I'm out of here. See you in 500,000 years or more. Never imagined that would have happened. And luckily, if it happened, I mean, they put the likelihood at less than 2%, which seems kind of low to me, but hey, they're the experts. So this is not likely, people, because there's a lot of unknowns. This is the part of the cloud that the sun went through that they calculated in their model was very small. So it's kind of hard to see if it really did go through it. So they're not extremely confident that this had to happen, but there's some interesting evidence supporting this contention. And I'd love to see what future research reveals. Interesting stuff.
All right. Thanks, Bob. Evan, what are prebiotics?
Oh, those come before biotics.
That's right.
Prebiotics. Yes. Well, I'm sure you've heard of those,
Yeah.
and I'm going to get to that as part of this particular news item, Steve. Now, there's an old expression. You can't have your cake and eat it too. I'm sure you've heard that before. And I'm sure if you were to search online, they would say it came from Mark Twain, and which means he really didn't say it. So,
yeah, right.
I did look up the expression online. To me, that phrase has always had a specific meaning for me. To me, it means you can never satisfy all of your desires. It's like a lesson in humility. Don't become spoiled, because not only is being spoiled not the best behavior, it's because it's kind of fanciful to think that things are always going to work out for you in every way throughout your life, right? So I'm replacing that expression today with, you can't have your soda and your health benefits too.
Yeah.
And that's because this news item has to do with soda pop, sometimes they call it. A soft drink, a class of non-alcoholic beverages, almost always carbonated, containing a natural or artificial sweetening agent, edible acids, natural or artificial flavors, and sometimes juice. Soda is also entirely unnecessary in a person's diet. The benefits are few, if any, beyond really being a basic source of hydration, and studies have shown that too much soda consumption can have adverse effects, such as adding too much sugar to a person's diet. And Steve, you talked about that earlier. But what if you infused something that was healthy, or supposedly healthy, into a soda's recipe? Would that not be a selling point for people? Yeah, now you can enjoy your soft drink and get some measurable health benefit from it, having your soda and your health benefit too. And that has happened in recent years. There have been some brands that have popped up touting this. Olipop is one of them. Vina. Those are two examples of recent new soda companies offering fortified soda drinks. Now, there's one in particular named Poppi, Poppi.
Hi, Poppy.
Poppi, and I've seen it on my shelves, definitely. And their soda products, ironically, have gotten them into some hot water, because Poppi is facing a new class action lawsuit that argues the brand overpromises on its health claims. A woman named Kristen Cobbs brought forth this suit in California, and her lawyers stated in the complaint that the soda lacks any meaningful health benefits. What are the claims, therefore, made by Poppi? Well, I went to their webpage to find out. And I pulled a few things. Making pop history, they say. Founded by husband and wife duo Stephen and Allison, no last name given, based in Austin, Texas, Poppi combines fruit juice, apple cider vinegar, and inulin prebiotics for a deliciously refreshing, full of flavor soda.
The hell's that?
Inulin prebiotics. Yep. When you have these prebiotics, they will pass through the stomach. They will not get absorbed in the stomach. Instead, what they'll do is settle in the bowels in order to help certain beneficial bacteria grow. Ultimately fermented in the large intestine by microbes that transforms the fibers into new compounds such as short-chain fatty acids. And studies suggest that these fatty acids can have beneficial effects on inflammation, appetite, and blood sugar levels. Okay. So, still reading from their website, with the help of an investment on Shark Tank, I don't know if any of you guys watch that particular television show, Poppy has gone from farmer's market favorite to sitting pretty on the shelves of every major retailer across the nation. Along the way, we've become beloved by some new besties like Post Malone, Hailey Bieber, Kylie Jenner, Billie Eilish, Russell Westbrook, J-Lo, Olivia Munn, and more. Now, there's nothing like having celebrity endorsements, right? We're bringing soda back, so they say. The twist, it's better for you this time. No more hiding cans in the bottom of your recycling bin or sipping sparkling water with your burger and fries. You deserve that mouth-watering swirl of flavors and bubbles without feeling bad about it. Get all the soda feels with 5 grams of sugar and 25 calories or less, and prebiotics. There they are again, the prebiotics. A special type of fiber that can act as food for healthy bacteria in your gut. Can of Poppy includes, is it agave inulin? Am I pronouncing that right? A-G-A-V-E?
Agave.
Yeah.
Agave plant, right? Agave inulin, which is a prebiotic and natural sweetener extracted from the agave tequilana plant. And it goes on. Oh, there was one funny section in their Q&A I thought would be interesting to bring up at this point. In their FAQ, right, it says, is Poppy organic, vegan, gluten-free, non-GMO, and kosher? Organic. Well, we use some organic ingredients, but it's not certified organic. It is vegan, but it's not certified vegan. It's gluten-free, but not certified gluten-free. But all flavors of Poppy are non-GMO project verified. So there you go. No GMOs made in the production of this particular soda. But here we go. Doesn't matter because lawsuit is going to claim that, hey, you're not saying what, you're false advertising here, folks. Your health claims are bogus. This is from the complaint. This is what they filed in court. Poppy's success is largely owed to its ability to preserve the flavor and sweetness of traditional soda while claiming to be gut healthy, in quotes, due to its inclusion of prebiotics, in quotes, a specific type of dietary fiber commonly found in food like bananas and whole grains. However, defendants' Poppy's soda only contains 2 grams of prebiotic fiber, an amount too low to cause meaningful gut health benefits for the consumer in just one can. Accordingly, a consumer would need to drink 4 or more sodas in a day to realize any potential health benefits from its prebiotic fiber. And if you were to do this as a consumer, Poppy's high sugar content would offset most, if not all, of these purported gut health benefits. All right. The document also quotes a woman named Deborah Cohen, who is a professor in the Department of Clinical and Preventative Nutritional Sciences at Rutgers University, who says, yes, these sodas are basically sugared water and not much else. Prebiotic sodas aren't going to do anything magical for your health, says Marion Nessel, an emeritus professor of nutrition, food studies for public health at NYU, and the author of a book called Soda Politics, which examines the soda industry and its marketing tactics. She says if they're making them as having a major prebiotic effect, that's an exaggeration. The evidence behind it, not so strong. Yep, a closer look at the underlying science of these microbe-based treatments shows that most of the health claims for prebiotics are hype. The majority of studies to date have failed to reveal any benefits in individuals who are already healthy. The bacteria seems to help only those people suffering from a few specific intestinal disorders. There's no evidence to suggest that people with normal gastrointestinal tracts can benefit from taking these products. If you're not in any distress, I would not recommend them. And that comes from Matthew Ciobara, a gastroenterologist at Washington University in St. Louis. The claims that they are making are enormously inflated. So the company had a response, basically, to this lawsuit.
Yeah?
Yeah. Spokesperson for Poppy Food and Wine, which is the official company that owns them. We are proud of the Poppy brand and stand behind our products. We're on a mission to revolutionize soda for the next generation of soda drinkers, and we have diligently innovated to provide a tasting experience that millions of people have come to enjoy. Sounds like an advertisement. We believe the lawsuit's baseless. We're going to defend these allegations. Yeah. So, there's I think a decent amount of studies that have been done on prebiotics out there, Steve, that say no.
Obviously, the idea is that the prebiotics are going to increase the good bacteria in your gut, and not the not good bacteria, right? So it's going to improve the probiotic, the bacterial profile of your GI system. There's just precious little evidence for it, and there's, some studies would suggest it may do that. Like one systematic review I read from about a year ago, looking at it for constipation, where like that's a very plausible, target for that kind of intervention, said that, there may be some benefit, but this data can't tell us which formulation helps. So how can you show that it's helping but you don't know which formulation is helping? That just tells me that the data was just all over the place. And then, it's looked at for a lot of other specific things. Like there was a systematic review recently looking at prebiotics and probiotics and synbiotics. Have you come across that term, Evan?
No. I've heard of postbiotics, but not synbiotics.
Synbiotics, S-Y-N.
S-Y-N.
Synbiotics are when you combine a prebiotic and a probiotic that are matched so that like the prebiotic supports the probiotic. They are synergistic, right?
Okay.
So anyway, this showed that the prebiotic by itself had no effect. There may be basically a little bit of benefit from the probiotics, but not for the prebiotics. Although the probiotic data is also pretty weak, And again, the only time we see maybe there's a signal maybe is when you're treating a gastrointestinal disorder. There is really no evidence that taking either probiotics or prebiotics is of any benefit, as you say, to healthy individuals. Like just as a health maintenance thing, like just routinely take it and you're helping your gut bacteria somehow. It's just, there's no evidence for that. The bottom line is that, your bacteria in your gut is a complex ecosystem and you can't alter it lightly, right?
And a lot of people from their normal course of their diet get enough of the prebiotics anyways. I mean, it's in a lot of foods. If you go to WebMD, they'll list a whole bunch of foods that
it's basically fiber. So
it's fiber.
Yeah, just eat your fiber.
Fiber. Which is in so many. Bananas, onions, apples, asparagus, oats. Whose diet does not consist of some of these things? Garlic, chicory root, dandelion greens, and there's many, many more.
Yeah, if you have a varied diet with enough fruits and vegetables in it, you're fine. And if you don't, taking some prebiotics is not going to help. And in fact, the very likely negative impact is to give you a false sense of security. It's like, well, I have a crappy diet, but I take my prebiotic soda, rather than I really should like eat some fruits and veg, there's a unintended consequence. It's marketing hype at this point.
Yep. And one more thing specifically about the agave inulin is that it's not without its problems as well. They say it's high fructose content, right? Contains 90% fructose. That's more than table sugar, which, obviously can have problems. This could reduce insulin sensitivity, which can worsen liver health and lead to chronic ailments like fatty liver disease, diabetes, and oxidative stress. Agave is also higher in calories than table sugar. So, just to throw that out there into the formula as well, that they didn't find some special plant that's doing something that's entirely 100%, healthy for you without any negative side effects to it.
Yeah. All right. Thanks, Evan.
Yep.
So, guys, quickly, I just wanted to give an update on deep brain stimulation. There's an interesting study that came out a couple weeks ago. So, deep brain stimulation, the ability to stimulate the deep parts of the brain, pretty self-explanatory, that you want to intervene on, either increase or decrease the activity of the brain in order to treat, neurological conditions, modify neurological symptoms, etc. There's always been a challenge of stimulating the deeper parts of the brain in that any electrical or magnetic signal that you use has to go through the superficial parts of the brain first, right? And so you can't target a deep brain structure without also affecting the overlying structures, which then causes unwanted effects. So the study figured out a way to do this, to stimulate the deep parts of the brain without having any effect on the overlying brain tissue. Anyone want to hazard a guess as to how they did it?
Yeah, I will, because I know that there was a technique for dealing with deep brain tumors by using not one powerful laser that will slice a hole through the whole way to the tumor, but a lot of low-powered lasers that on their own don't do any damage, but when they converge in the middle, that's where the focus is. That's where the heat is. So the outer layers of the brain are spared. So is it a similar technique where it's like multiple,
it's a good guess.
Magnetic fields merging?
It's a good guess, but it's not multiple. It's only two. So how would using just two fields work?
Do they enhance each other? The constructive interference somehow?
No, it's the destructive interference.
Destructive.
So so it's interference. Interference is like magic, when you're dealing with stuff like this. So they basically use a 2,000 hertz and a 2,080 hertz frequency. The 2,000 hertz basically cancel each other out. And so at the point of intersection, you're left with an 80 hertz electrical frequency. And that's the frequency that affects the brain function.
That's awesome.
The 2,000 hertz is too fast. It does not have any effect on brain activity, right? So the two beams themselves don't do anything. But when they intersect, you end up with this 80 hertz of electrical field that does influence the brain only at the point of intersection.
That's amazing.
Yeah, so
figure that out.
So basically they're calling it non-invasive deep brain stimulation. So what could this be used to treat? Well, it could be, right now we do deep brain stimulation. We're basically sticking a wire in the brain, right? Or we're doing it by stimulating a nerve, like the vagus nerve, which already is wired to the deep brain. But this way you could just do it without any physical structure, without having to put anything into the brain, just doing it with external electrical fields, but just modifying, just directing them and modifying their frequency so that you get an effect only at the deep tissue. So you could use this theoretically to treat seizures, to treat things like migraines, to treat things like tremor from Parkinsonism. And now that we could do it non-invasively, perhaps even a host of other things. Basically, when you have the ability to alter brain function, that opens the door to a lot of potential applications.
Oh yeah,
yeah. So this is a neat little trick they came up with. Pretty cool. All right, Jay, it's Who's That Noisy time.
All right, guys. Last week I played this noisy. Did you hear that?
Yeah.
Yeah, something hooped or hollered in the background there. It's kind of.
I got a ton of people guessing this week. Listener named Simon Armstrong said, "Hi, I've taken to playing WYN with my kids." That's Who's That Noisy. That's what he's trying to say. With my kids on the way to school over the last few weeks. We've never got it exactly right, but certainly got it close a few times. So I always like the kids' guesses because they're unhinged. So his daughter Charlotte said, "People screaming in the waves." Right? Noah, who's 9 years old, said a rotary sander starting up. And then Simon, who is an adult, said the servo motors that drive some arm or appendage on a Mars rover. Simon, you actually touched on a tiny little bit of the answer there, but we'll keep going here.
Ooh.
Another listener named Colin said, "Hey Jay, Visto Tutti must be a pseudonym, right?" And I don't think it is. I think that is Visto's real name.
No, I think it is a pseudonym. It means I see everything. Visto
he'll have
Tutti.
to. Yeah, I know. He said that. The guy that wrote in Colin said that it means see everything, but that could be his name. I don't know. Only he can tell me. He's a very difficult person to get in touch with.
I thought he said.
So he said, "I heard the sound of the Orion spacecraft re-entering Earth's atmosphere." That's an interesting guess, but not correct. Another listener named Martin DeVries wrote in and said, "Hi gang, love you all and all the work you do. Thank you so much for sticking with this." He's saying because we've been doing this for 20 years. He continues, "I think this week's noisy sounds like windshield wipers dragging across a dry windshield." And you know what? It does sound like that a little bit. You definitely heard something legit in there because I have heard that many times. Another listener guessed, this is Cameron from Houston. He says, "This week's noisy, a ball bearing being spun to a high RPM by compressed air. This is a fairly common shop pastime for industrial electromechanical technicians, which I am one. I've seen a video of that. I don't quite remember the sound, but that is an interesting guess." And then I got another guess here from a listener named Darwin. And he says, hello, SGU. This may be my first, maybe second ever guess. Is this an electric motorcycle? I'm not sure what make model. It is not. And I have heard one, but it didn't make noise. So it made a little bit of like road noise, but didn't have any engine noise. All right. So guys, I gave the win to 2 people because 2 people guessed within moments of each other. I usually pick the first people that write in that guess it right. So the first one, the guy that actually won is Brandon Binczak, Binczak, Binczak. Okay. He says, hey, Jay, long-time listener, first-time guesser. If the noisy is what I think it is, I'm sure a million others will get it. That's not correct because there was only 2 people that got it. He said, it sounds like the servos changing the flap position on a jet aircraft.
Oh.
He is correct, and this is why I actually picked 2 people as well. Because it is servos on a jet. They're not actually changing the flap position, but these are airplane servos that you're hearing. So let me go down to the ultimate correct answer. So Mike Dreyer guessed, hey, Jay, for the first time ever, I think I know this one. This sounds like the exhaust nozzle opening and closing on a Pratt & Whitney jet engine. These are for F-16s or F-15s. That is what's happening. So if you can visualize this, you have the 2 engines on the back of an F-15. Those 2 engines have an exhaust area in the very back. In that very back area, there are servos that control the aperture of that opening. Mm-hmm. But not the way a camera does it. It does it with a bunch of they're almost like fingers that are all touching each other that can narrow or widen the opening. And I in a quick search, I couldn't find out why they do that. I'm sure it has a lot to do.
It directs the flow of the exhaust.
Yeah, I'm not sure it's like a jet engine, like a rocket engine that can actually change the angle. I think it changes the compression, but I'm not 100% sure. But anyway, that is what is happening here. So the back of the engine can open and close, and this is the noise of it closing. Let's listen to it again. Yeah, that high-pitched noise is the servos running to change that. So that's very cool. Very cool. Another bit of engineering that is hidden there on the plane. If you don't look closely, you might not even notice it. Do you guys know that I knew a guy that used to be an F-15 fighter pilot, and he made a fatal error on the runway. Not fatal, nobody got killed, but it was a really bad mistake, and he exploded the engine of an F-15 fighter jet.
Whoa.
Yeah.
Oh.
Which
That's not
What,
cheap.
he hit the explode button?
No, he did something. It was I'm trying to remember the story, but he definitely did it. It exploded it, and that was it. That was the end of him flying
God.
Jets, because they have, I guess, zero tolerance for any of that shit. So anyway, I have
Yeah, you can only destroy $20 million of property at a time, right? In one lifetime.
You can't make that mistake. You just can't do that. I do have a new noisy for you guys this week. This noisy was sent in by a listener named, you like to hear it? And here to go.
Oh my God. I don't know what it is, but I want it.
So this one, I'm like, this could be one of my favorite noisies. It could be so many different things. If you think you know what this noisy is, or you heard something cool, don't hesitate. Email me at wtn@theskepticsguide.org. Steve, we've been doing this podcast for 19 3/4 years.
Yeah, this is episode 988.
Yes.
Oh.
We are on the cusp of our 1,000th episode. So if you have been a listener of this show, and if you appreciate and enjoy the work that we do, that we continue to do after all these years, there's one thing that you could do to help us more than anything else, and that would be to become a patron of the SGU. Now, did you know that you can become a patron for even $1? You can become a patron. You basically can pick whatever dollar amount you want. There are different levels to our patronage. Most people are at the $8 a month level. That's where you get the ad-free episode. But you could become a $5 member, and you will be able to get on our Discord, which, again, we have, I would argue to say, probably the absolute best Patreon community membership people. These people are awesome. I've met a ton of them, and I've become friends with many of them over the years, and we have a great group. And if you're one of those people that is stuck somewhere in the world and you live in a place where there aren't a lot of skeptically minded people, this is your way to make a bunch of friends who will agree with you on most things. But anyway, yeah, we would really appreciate it if you consider becoming a patron. It really helps us, and it also helps us make big changes. I'm not going to say what those are, but we have plans. Anyway, you can go to patreon.com/Skeptics Guide. If you're interested, take a look. Steve, what do you think about people becoming patrons of the show?
I support it.
There you go.
Yeah.
What else do you need? Support it.
I
Now, if you don't want to become a patron, you can't swing it. You can also or join our mailing list if you're interested. Just go to theskepticsguide.org and there's a button there to join our mailing list.
Join us.
And also, we used to say this a lot early on. It's still relevant. You could leave a review for us on any place that will accept a review. I know the Apple reviews are still very powerful out there. Help people find us. You could also tell friends about the show. Anything you could do to help support us, we'll appreciate that. So giving us a rating on your podcast player would be very helpful. We have open shows right now for tickets. If you're interested, we're going to be in Chicago the weekend of the 17th and the 18th. We have multiple shows that we're doing. There are tickets available for 2 shows. One show is the early afternoon extravaganza. If you're interested for that show, you can go to theskepticsguide.org. And the big one, the 1000th live 5-hour episode.
Whoa.
I have been going through all of these submissions that have been given to us by people who are picking their favorite moments and everything. And my God, guys, we have had a lot of fun and funny moments throughout the years.
Heck yeah.
And I'm starting to make this master list. So here's what I decided to do. I was talking to Kelly about this. We're going to make a list. We're going to pick all the ones that we like. Any one that we hear that people submit. These are just little clips from the show that were funny or insightful or anything that is noteworthy. But the humorous ones are the ones I'm really looking for. I'm going to compile like the list of all the ones that are above the waterline. And I'm going to make those accessible to the patrons after the 1000th show. They're going to get the whole list of everything that everybody did. And I will be, taking the sound bits and making like a master list of all these, or at least a folder filled with them separated. But during the show, during the 1000th show, we will be, playing the top choicest of the best of the best, the funniest, the most bizarre, all of that we will be playing during that show live. And a lot of that will not make it to the final episode because, Steve, you're going to reduce the 1000th show down to a 2-hour or 1.5 hour regular episode, right?
Regular duration show.
Yeah. So the vast majority of that content during that show is not going to be made available to the public because that's, people are buying tickets to see the show. So, we're going to give them the special opportunity of experiencing that. But patrons will have access to all of the good ones that I find. So anyway, so we think that you guys should really consider coming to the show. It's going to be great. I guarantee you this will only be, I'll try it again, Steve. I guarantee you we will only record one 1000th episode. That's it. We're only doing this once because there can be only one.
All right. Thanks, Jay. All right, we're going to do one quick email. This one comes from Adrian Tello from Texas. Yo, Adrian.
Yeah. Right? I mean, how can you see the name Adrian, how can you not think of Rocky in a way?
He writes, hello, fellow skeptics. I've been listening to the SG for almost a decade now and really enjoy and appreciate what you guys are doing. Critical thinking is needed now more than ever.
Yep.
Have you guys discussed the Bader-Meinhof phenomenon before? Apparently, it is a frequency illusion where when you hear about something, it all of a sudden appears more frequently. Learning about a new person and all of a sudden the person's name appears everywhere. I have a sense that it is a cognitive bias. Would like to especially hear Stephen Kerr's take on this subject. Sorry, Kerr's not here, so I'll have to solo this, Adrian. So guys, have you heard of the Bader-Meinhof phenomenon before? I know we've mentioned it on the show, but you may not remember it.
Yeah, I remember that. I experienced a version of it just recently, Steve. In the span of say a week to 10 days, I kept seeing over and over a license plate with BN, my initials, at the first 2 letters of the license plate. And after I saw a couple of them, I was seeing them almost every day and almost feeling weird. Wait a second. I mean, is this really happening? But then I realized, of course, that this is just, I'm tuned to notice it now. But damn, it just seemed like too much. It's holy crap.
So
it was powerful.
I actually think, though, that may not be Bader-Meinhof because...
It's a form of it, isn't it?
Well, the thing is, that license plate numbers are not random, they're sequential. And
they're sequential.
When you get to BN, then all the BNs get put out there, whatever, like 1,000 of them or 10,000. What is it, 4 numbers afterwards?
There's five numbers after the 2-letter code, so you've got...
It's a lot.
Could be 990,000.
Yeah, so you just get to that point where you notice that there are BN license plates out there, and of course there's a ton of them out there because they all come out at once, in terms of all the new ones being issued.
That's an interesting angle.
Yeah, so it's not pure. It may actually be that there's an increased frequency. But anyway, the history is interesting. The term Bader-Meinhof actually refers to a German terrorist group. Yeah. But the guy, Terry Mullen, who coined the term in 1994, that was his first example. He heard that name, Bader-Meinhof, and then kept noticing it everywhere. And so then he made that observation, and that's the name that stuck to the phenomenon, right? But yeah, I mean, that's happened. It happens every now and then where like you learn a word you never knew of before, or you hear about a person that you didn't know existed before, or a phenomenon, or whatever. Like I remember the first time I heard Bader-Meinhof, I started seeing it everywhere. But then you notice it like multiple times within a short period of time. Yeah. And it seems like an incredible coincidence. So which of course there isn't any cosmic coincidence going on. It must be that there's some cognitive, perception illusion going on here. So yeah, the frequency illusion is just a reference to the noticing this itself. But what's causing it? What's the underlying phenomenon? Two things have been proposed. One is confirmation bias, which I don't really think is exactly correct. We talk about confirmation bias
it's a little off.
It's not quite the answer. I think the answer is selective attention, which is the other one. That the first time you hear about Maxwell's equations, you then hear about it 3 more times the next week.
Yeah.
Or whatever, just anything. The thing is, you probably have been encountering that your whole life or whatever over the last decade or some chunk of your life, depending on what the word is and for how long it's been out there in the popular culture. But you just didn't notice it. You didn't notice it because you weren't aware of it, and you only notice things you're aware of. So when you become aware of something, you start to notice the frequency that was already there, right? I think that's the core of the phenomenon. It just shows you how much we're exposed to and the tiny slice of that we actually notice, process, remember. And it's all based upon what we already are familiar with and already know. And I also, thinking about this, I did realize at some point, it's like, I hear a lot of things that I don't know what the reference is to, and I just let it slide. You know what I mean? Like, I just don't. You hear a word, you don't know what it means, you just forget about it. Like it's not worth my time and attention right now to figure out what that is. And you don't even go through that conscious thought. It's just that it slides off, and it doesn't peak above the radar. At some level, I am aware that I've heard a name that I don't know, or a word that I don't know, and I just sort of move on in my life and don't pay attention to it. And then you realize that, if I had recently learned what that was, that would be a Bader-Meinhof. I would then have absolutely noticed that, because now it's on the top of my head, right? Reading about this, I also came across something called the split category effect. Have you guys heard this?
No.
This is kind of a very niche split kind of bias. Category. Yeah, so if I asked you how many dogs do you think live in Connecticut, and then you give me an estimate, and then I said, okay, how many poodles do you think live in Connecticut? How many Labradors? How many bulldogs? How many beagles?
That would never add up to the original number.
No,
right?
If I ask you that, it adds up to more than just the total. How many dogs? Because it's just that you tend to, like, if each subcategory is a little bit inflated, it inflates your overall estimate of the whole category. If you start to look at things in terms of subcategories, it creates the illusion that there's more of it out there than there seemed to be when you were just lumping them all together into one big category. Does that make sense? Again, it's kind of a niche
Totally
perceptual
makes sense.
bias. Yeah. Maybe that could cause some cases of Bader-Meinhof. But again, I think the core phenomenon is just we only pay attention to a very tiny slice of the things that we come across every day. And yes, if you're made aware of something, you're going to start noticing it. It was always there. You're just noticing it now.
Steve, a parallel I could think of is when you described when you first started watching birds intently, and the details that you would notice later on that you never noticed early on.
Right. Yeah, these birds were always there. I just didn't know they existed. Yeah, there was sort of a Bader-Meinhof of birds. Like once I learn a bird, I start to see it because now I know what to look for. It's part of my lexicon, All right, let's move on with science or fiction.
It's time for science or fiction.
Each week I come up with 3 science news items or facts, 2 real, 1 fake, and I challenge my panel of expert skeptics to tell me which one is the fake. Just 3 regular news items this week. You ready? Total silence.
Not a peep.
All right. Item number 1, researchers unveiled a new computer modeling system of a living cell that is 1 million times faster than existing simulations. Item number 2, for the first time, physicists report they have been able to isolate true magnetic monopoles. Item number 3, NASA recently successfully tested their new communications link to the ISS, which was able to transmit data up and down at 1.2 gigabits per second. And yes, that's gigabits. Bob, go first.
All right, so...
Your silence did not save you.
Well, he laughed.
Week, Bob.
All right, start with 3. New communications link to the ISS, 1.2 gigabits per second. Yeah, that sounds reasonable, especially compared to the first 2 here. Up to number 1, got a new model of a living cell. Yeah, okay, 1 million times faster than existing simulations. I mean, that's quite an increase. But sure, they could have come up with some algorithms to speed it up, and it seems like overly dramatic in terms of such a huge improvement. But then I look at number 2 again here. A physicist reporting isolating true magnetic monopoles. I don't believe that. I'll say that's fiction.
Okay, Jay.
That's all you're going to say about that, Bob?
I don't believe it.
He is skeptical.
All right. So NASA recently successfully tested their new communications link with the ISS. It was able to transmit data up and down at 1.2 gigabits, 2 gigabits. Yeah, that one. I think that one is science. I mean, distance is hard to travel. Yeah, speed of light. Okay. Yeah, maybe. Yeah, I mean, that one seems okay to me. I'll go to the first one. I agree with Bob. Like, yeah, 1 million times does sound a lot faster, but how many people have been working on that, and maybe going from where they were to 1 million times faster was just people paying more attention to it. Maybe that isn't that big of a feat. I'm not sure, but I think I'm going to agree with Bob that physicists have not been able to isolate true magnetic monopoles. I agree with him, Evan.
That's all you're going to say, Jay?
Why do you agree with me? Yeah, is that all
the way that you said it, Bob, the way that you exhaled.
Oh.
Yep.
The exhalation. Yes. That's my tell. Gotcha.
Oh, I thought he was sipping on coffee.
Nah.
All right, and Evan.
Well, I'm going to take these in random order. Number 1, the new computer modeling system of a living cell 1 million times faster than existing simulations. Impressive and plausible. So I agree with the guys that this one is going to be science. Number 2, about the isolating true magnetic monopoles for the first time. You mean they weren't able to do this before? I do not understand the significance of this, which, Steve, I'm sure you'll explain what the significance of that exactly is. So I'm a neophyte when it comes to this. And then the third one about, 1.2 gigabits per second. I'm interested to see how they did it, or what technology they're using for this. Is it just as is it something super special that only NASA's allowed to use? I'm in the dark here about the magnetic monopole, so I'll join on Bob and Jay, and we will sink or swim together.
Well, I think you guys find the third one the most believable, so we'll start there. NASA recently successfully tested their new communications link to the ISS, which was able to transmit data up and down at 1.2 gigabits per second. You all think this one is science, and this one is science. Yep, this is science.
Nice.
Yeah. So what do you think they're using?
Lasers.
Lasers is correct. What frequency?
1.2 gig.
220 nanometers.
Well, give me a description.
That's all I got.
Infrared.
Yeah.
So instead of radio waves, they're using infrared.
All right.
So that's more. You can get more data, in the because the wavelengths are smaller than radio waves. So infrared lasers. They actually shoot them up to satellites in geosynchronous orbit and then down to the ISS and then back the other way.
They tried a fiber optic cable, but it didn't really work out too well.
But 1.2 gigabits, that's like faster than my connection, my fiber
That's
optic
pretty
connection
damn sweet,
here.
man.
Yeah. That's sweet.
Seriously, let's have lasers going all over the world here connecting us.
So it's very important, obviously, for NASA to be able to communicate with all of the stuff up there. And, I think they're partly... they have to communicate with not only all the satellites, but also now spaceships and everything. And as they're planning on, putting more stuff into cislunar space, having a reliable, fast communications especially since you have to download lots of very high resolution pictures and get a lot of scientific data up and down. This is very important. So this was a good, successful test. All right, let's go back to number 2. For the first time, physicists report they have been able to isolate true magnetic monopoles. You guys all think this one is the fiction. And this one, well, let me just read you the title of the article.
Here we go.
This is published just this year, 2024. After a century of searching, scientists finally found a virtual magnetic monopole.
What, virtual?
Virtual. Wait.
It's a virtual shit.
Not a true magnetic monopole.
Well, there's two. This is the fiction. You're correct. I didn't think I was. I was stretching with the monopole thing. I think that was one of the I would have heard of it kind of news items. But
absolutely.
But scientists,
that will be huge.
So the idea of all magnets have a north and south pole. If you take a magnet and you divide it in two, you get two magnets, each with its own north and south pole.
Yeah.
And so physicists have theorized going back 100 years that, well, maybe under certain conditions, whatever, it might be possible because of quantum mechanics. Like without quantum mechanics, classically, no, you can't have a magnetic monopole. But maybe quantum mechanics allows for the existence of a magnetic monopole. And just in the last year, there have been a few studies showing the existence of magnetic monopoles, but only in very specific conditions.
Like freezing cold temperatures?
Well, like certain kinds of quantum matter, but here's the other thing is they can't isolate them. So you have like magnetic monopoles and then anti-monopoles, like the opposite poles. And they are monopoles, right? But they can't be separated out and isolated from each other. So that's the thing. So they haven't isolated true magnetic monopoles.
So they're monopole-ish.
Yeah, and the ones that occur, the virtual monopoles, they're things that behave like monopoles. They're not exactly actually monopoles, but they behave like magnetic. They have the properties of a magnetic monopole.
Pseudo-monopole.
Yeah, that reminds me of they created a black hole in the lab. No, it's an analog to the black hole. It's like not really a damn black hole.
Right. So here's the point. Yeah. So here's one description of it. These monopoles are a collective state of many spins that twirl around a singularity rather than a single fixed particle. So they emerge through many body interactions. Okay. I'll take your word for it.
Right.
Yeah, the result is a tiny localized stable particle with diverging magnetic field coming out of it. And that magnetic field basically behaves like a monopole in one direction. And then there are two different directions. Either they're pointing out or pointing in. They call them, monopoles and anti-monopoles. So far, note you have not isolated a true magnetic monopole. This
doesn't
means
seem good like they ever will.
Yeah, Maybe. This means that researchers unveiled a new computer modeling system of a living cell that is 1 million times faster than existing simulations. Is very cool science. This was a partnership of researchers from the University of Kansas, collaborators in Europe, including Ukraine, despite the wars going on over there. And yeah, this is what it sounds like. It's a very detailed simulation of a full living cell, including the DNA, protein creation, all the molecular stuff going on. And what they want to be able to do is say, okay, what happens if we make this genetic change? What happens to the cell when we do that? Or what happens if we introduce a drug that binds to this receptor? What happens to the cell? The principal investigator, Vaxer, is quoted as saying, "The approach we put forward is about 1 million, and I mean 1 million times faster than alternative approaches developed elsewhere." Mm. Obviously, this could be a huge boon to drug development, to disease research, to biological research in general. It's basically, you take everything we know about the cell, then you could ask the question, what happens if, right? And then you perturb it in some way and see what happens.
Well, that's the rub. I mean, are you saying it's detailed enough that they can, have that level of granularity where you could say what happens if we just change?
Yeah, that's what they're saying. I tried to find a description of like what percentage of actual stuff happening inside a cell are they simulating. I couldn't find like a number to represent that, but I would guess that's where it kind of. But it seems to be pretty high. I don't think it is a whole cell simulation. That is the point of the simulation. Again, how much detail they drill down to is an interesting question. But enough to do this kind of research, right? That's the whole idea.
That is huge. I've been talking about stuff like that for quite a while. Where once we get simulations at that level, then you could really. You won't need to, at least initially, or at least eventually, you won't need to you do the research on living cells at all. You could just simulate it as a good first step before you even go to the living cells. That would be a way to really speed up a lot of crazy research, man. That's intense.
Yeah, and in general, it's like one way to use computer models is you do as much research as you can in the model first, so that before you get to physical research, whether it's chemical interactions or animal studies or whatever, you have narrowed the list of possibilities, or you know exactly what you're supposed to be looking for or whatever. So that, years of research is now reduced to only months, for example. And you've done most of the research in computer models. It doesn't really replace everything else. It just informs it to the point where it's way more efficient. All right, Evan, give us a quote.
"Understand well as I may, my comprehension can only be an infinitesimal fraction of all I want to understand." Ada Lovelace.
Nice. You want to tell it?
Ada rocks.
Ada rocks. I was looking up a quote by Charles Babbage, actually, and I'm like, I wasn't impressed. But Ada Lovelace, Babbage. I'm like, oh, wow, yeah, that's great. This is
Babbage never finished his damn machine.
So wasn't she basically the first computer programmer? She was a mathematician.
Pretty much.
Yeah.
She's credited, certainly. English mathematician and writer, chiefly known for her work on Charles Babbage's proposed mechanical general-purpose computer, the Analytical Engine.
Yeah.
She was the first to recognize that the machine had applications beyond pure calculation.
She was fantastic.
Brilliant.
Pioneer.
Just what a brain. What a brain.
Yeah.
Thank goodness. Thank goodness for some people.
All right, well, thank you all for joining me this week.
Sure, man.
My pleasure,
Thanks,
brother.
Steve.
And until next week, this is your Skeptic's Guide to the Universe. Skeptic's Guide to the Universe is produced by SGU Productions, dedicated to promoting science and critical thinking. For more information, visit us at theskepticsguide.org. Send your questions to info@theskepticsguide.org. And if you would like to support the show and all the work that we do, go to patreon.com/skepticsguide and consider becoming a patron and becoming part of the SGU community. Our listeners and supporters are what make SGU possible.